Okay, imagine you're staring at, like, a puzzle, a set of lines and symbols, and they're supposed to tell you how to build something, maybe something amazing like that dream shed for the backyard, or even a whole building.
Right.
It can feel like you're looking at a secret code, can it?
Absolutely. And, in a way, that's kind of what technical drawings are.
Uh-huh.
They're basically the universal language that the designers and builders use
Yeah.
to communicate exactly what needs doing. Think of it as the ultimate instruction manual for any construction project.
And today, we're going to try and crack that code a little bit. We've
Yeah.
got some really helpful info here, looking at the core ideas behind these drawings.
Yeah.
The goal is really to help you get the main principles without getting lost in, all the complex jargon. We'll look at basic geometry, the foundation,
Right.
then zoom in on specific things like doors, roofs, even how a building sits on its land.
Exactly. And each of these drawings, they have a very specific job to do in the whole construction process. We'll kick off with geometric constructions, the real fundamentals.
Okay.
Then look at how a specific part, say a panel door, gets detailed. After that, we'll sort of climb up to the roof design, then step back for the site layout.
And wrap up with why we even need all these different drawings.
Precisely. Why they're necessary.
So hopefully, by the end of our chat, you'll be able to glance at some plans and have a much clearer idea of what all those lines and shapes are actually saying.
Yeah.
You'll start seeing how they pass on all that essential detail needed to, well, build the world around us.
Right. Let's dive straight into the basics then.
Yeah.
Geometric drawings. These are really the foundational skills in technical drawing.
Okay.
And it's pretty amazing what you can achieve with just two simple tools, a compass and a ruler. They let you create incredibly precise shapes and angles.
Compass and ruler, simple enough. Takes me right back to school. Now, one of the first things you often hear about is bisecting an angle, just in, plain English. What's that mean? And where might we see that used in building or design?
Okay, think of an angle like, say, the corner of a room. To bisect it just means drawing a line that cuts that corner perfectly in half.
Right.
So you get two identical smaller angles.
Right.
Now, why is that useful? Well, precision and balance. They're often crucial in construction, right? Imagine designing a symmetrical feature like maybe a staircase where both sides have to rise at the exact same angle.
Ah.
Bisecting lets you find that perfect middle line to guarantee that balance. Or maybe dividing a piece of land equally. You need that exact halfway point. That's a kind of bisection too.
So it's about creating perfect halves for symmetry, equal division. Makes sense. Okay, what about constructing a perpendicular bisector? That sounds a bit more involved.
Okay, imagine you've got a straight line. A perpendicular bisector is just another line that crosses it in two very specific ways.
How so?
One, it cuts it exactly in the middle, the midpoint. And two, it hits it at a perfect 90-degree angle, like a perfect T-junction.
Okay, or right angle.
Exactly, and this is incredibly practical. Say you need to put a support post smack bang in the center of a beam. You'd use a perpendicular bisector to find that exact midpoint and make sure it's dead on 90 degrees for stability.
Right, for strength.
Or laying out a foundation for a rectangular building.
Yeah.
You need those corners to be perfect right angles. A perpendicular bisector helps you get that accuracy.
So finding the exact middle and creating those vital right angles. Got it. Now, looking at these drawings, it's not just one kind of line, is it? There are thick ones, thin ones, dashed.
Yeah.
What's the reason for all the different styles?
Oh, absolutely. Think of these different lines as like different types of information. Construction lines are super light, almost faint guidelines.
Okay.
They're temporary aids you use while you're drawing to get shapes and angles right. But they aren't actually part of the final object.
Just guides.
But you have object lines. These are thick, solid, bold lines. They define the main outline, the visible edges of whatever it is you're drawing. These really show you the shape of the thing.
Okay. Light for guiding, bold for the actual shape. What about those dashed lines you sometimes see, the ones sort of tucked away?
Right. Those are hidden lines. They show edges or features of the object that you actually can't see from your current viewpoint because, well, they're hidden behind another surface. Imagine looking at a box. You see the front edges, right? The hidden lines might show you an edge on the back out of sight. And you really don't want to mistake a hidden line for an object line during construction.
Yeah, that could cause problems.
You might cut something you shouldn't or put something in the wrong place.
Like having X-ray vision for the drawing. Makes sense. And the last type I remember is the center line. What's that telling us?
A center line has a specific pattern. Long dash, short dash, long dash, short dash. It repeats. This line marks the exact middle of circles or curves or anything symmetrical.
All right.
It also acts as an axis of symmetry. So if you see a center line running through a circle on a plan, you know precisely where the very middle of that circle is meant to be.
Gotcha. So these different line styles are basically a visual code, each telling us something specific. Okay, let's shift to something more tangible. A panel door. We had some measurements for one. How do we use the overall size to figure out the size of those inner panels?
Right. This is a perfect example of how the big picture breaks down into smaller parts. You start with the total height and width of the door.
The overall dimensions.
Yeah. Then you've got the stiles. Those are the vertical pieces running at the sides. And the rails, the horizontal pieces, top, middle, and bottom. Think of them like the frame around a picture.
Right, the structure holding it together.
Exactly. So to find the width of each panel, you take the door's total width and you subtract the width of the two stiles, one on each side.
Okay.
That's space left over. That's where the two panels fit side by side. So let's say our door is 914 millimeters wide, and each stile is 152 millimeters.
Right.
You subtract 152 twice.
Yeah.
So 304 total. That leaves 610 millimeters for the two panels.
And there are two panels, so you just have it.
Exactly. Divide 610 by 2. Each panel will be 305 millimeters wide.
So you take the total space, take away the frame bits, see what's left, and divide it up. Makes perfect sense. Now, what about the height? That seems a bit trickier with all those different rails involved.
It's the same basic idea, just vertically. The total height is, say, 2032 millimeters.
Okay.
Now we subtract the height of every horizontal rail. The top rail, 152 millimeter. The middle rail, which is wider, maybe 203 millimeters. And the bottom rail, often the widest, say 254 millimeters.
Right, add all those up.
Add them up. 152 plus 203 plus 254. That's 609 millimeters total for the rails.
Okay.
Subtract that 609 from the total door height of 2032. That leaves us with 1,423 millimeters.
And that's the space for the two panels, top and bottom.
That's the total vertical space the two panels have to fit into, one above the other. So again, divide that 1,423 by 2. Each panel ends up being about 711.5 millimeters tall.
So again, subtracting all the frame pieces leaves the space for the panels. And these calculations, they have to be pretty spot on, right? Because if the panels are off even a little bit.
Oh, absolutely. Precision is everything here. If those panel measurements are wrong, you'll have gaps or they just won't physically fit. These calculations make sure everything slots together nicely. Snug fit.
Okay. Now, the notes mentioned a sectional sketch of the door, like slicing through it horizontally.
Yeah.
What does that kind of view show us that, a normal front view wouldn't?
Think of it like cutting an apple in half and seeing the core and seeds inside.
Okay.
A horizontal section of the door shows the internal structure at that exact cut line. For our panel door, it would show the stiles on the sides. Then you'd see the wider middle roll going across.
Uh-huh.
And crucially, it would show that the panels are recessed. They sit back a bit from the front surface, those stiles and rails.
Like a picture in a frame isn't flush with the front?
Exactly like that. The picture sits behind the frame slightly. The sketch would also show any grooves or moldings in the wood, those shaped edges that actually hold the panels in place and often add a decorative touch. So it gives you a much better understanding of how the parts actually connect and create the whole door.
So it's an inside look at one specific level, helps you see how it's put together. Okay, let's look up at the roof now. A hipped roof, specifically. If we're looking at the framing plan from above, like a bird's eye view, what are the main bits we'd see?
Right. Looking down on the framing plan for a hipped roof, you're seeing the skeleton that holds it all up. One key piece is the ridge board.
Ridge board.
That's the horizontal beam running along the very peak, the highest point of the roof. It's like the central spine where other rafters connect.
Okay, the backbone, got it. What connects to that spine?
Running diagonally up from each corner of the building to meet that ridge board, you have the hip rafters.
Hip rafters.
These are really important for creating those sloping sides, the hips of the roof. Because they run diagonally, they carry a lot of the roof's weight.
So they're the main angled beams forming those sloping sides. And then there are jack rafters. What do?
Jack rafters are shorter. We fill in the gaps, basically. They run between the hip rafters and either the ridge board up top or the wall plate down at the bottom edge. They don't go the full length like hip or common rafters. Think of them as filling out the roof structure in those triangular sections created by the hips.
Okay, so they're like shorter ribs coming off the main hip structure. Makes sense. And finally, the fascia board. Where does that fit in?
The fascia board is that horizontal board running along the very outer edge of the roof overhang. Right where the roof kind of meets the top of the walls.
Oh, right.
Is often where you attach the gutters. From that top-down view on the plan, you'd see it outlining the whole perimeter of the roof structure.
So the fascia is like the trim board around the roof edge. Seeing that from above really does clarify how all these pieces interlock, doesn't it, to make the roof shape?
Exactly. It gives you a clear map of how the roof load is distributed and how all those members work together for a strong, stable structure.
Okay, let's zoom out even further now. How does the building actually sit on its plot of land? We mentioned a site layout plan. What's the main point of that drawing?
The main goal there is to show exactly where the building goes within the property lines. It gives really crucial info about the building's position relative to, well, everything around it. Boundaries, roads, maybe existing trees, utility lines.
So it's like the map showing the building's specific spot on its own piece of land.
Precisely. And to make it clear, site plans use standard symbols. You'll almost always see an arrow marked N. That tells you which way is north. Essential for orienting the building.
Okay.
Property lines, the legal edges of the lot, are usually shown as dashed lines. And the front setback, that's the minimum distance the building has to be from the road, often shown as a dotted line.
Right, defining the legal space and where you can actually build. What about things like water and power? How do they show up?
Utilities also get specific symbols and lines. A water main line might be a blue dashed line, labeled water. A power line would be marked similarly. If there's no main sewer, you might see a little box labeled ST for septic tank. These symbols are vital. The construction crews need to know where to connect services and, just as importantly, where not to dig.
Yeah, hitting a water main would be bad. So they're not just abstract symbols, they have real-world consequences. Okay, shifting from the outside in, the notes mentioned small building symbols within a floor plan. What are some common ones?
Right, inside a floor plan, which is like looking straight down into a building with the roof off, the symbols represent different elements. A door is usually a gap in a wall line with a little curved arc showing which way it swings.
Right.
A window is typically shown as maybe 2 or 3 parallel lines drawn across the wall line, marking the opening. Circular columns for structural support are often just small circles, and a step area, maybe going down into a sunken room, might be a small rectangle with lines across it for the steps.
So, visual shorthand for all the bits and pieces inside. We also had a note about labels A, B, and C. On a typical house floor plan, what would they usually point to?
In a standard home plan, yeah, if you see simple labels like A, B, C, they're usually pointing to the most fundamental things. A would almost certainly be an exterior door, the way in or out.
Right.
B would very likely be a window for light and air.
Makes sense.
And C is typically internal wall, while the wall's dividing up the space inside into different rooms. They're the real basic building blocks of any floor plan.
Okay, so even just knowing those basic symbols and labels gives you a much better feel for how a building is laid out. Now, all these different drawings, site plan, floor plan, elevations, they must each have a specific job during construction, right? Why the need for so many different documents?
Yeah, each type gives essential information, but for different stages and different people. Take the bill of quantities. That's used mainly before building starts.
Okay.
It's a detailed list of all the materials, all the labor needed. It lets you get accurate cost estimates and helps the client compare bids from different builders.
So it's the project's shopping list and price tag, basically.
Right.
What about the floor plan? How is that used day to day during the build?
The architectural or floor plan is really the main guide for the teams on site. It shows the exact layout of every room, all the precise dimensions where walls go up, where doors and windows are installed, where fixtures are placed. It's the core blueprint for actually building the structure.
Okay. And the site plan, the one showing the building on the land, what's its crucial role?
The survey or site location plan is vital for pinning down the building's exact position on the property. It shows the legal boundaries, any slopes or level changes on the land, locations of important site features, utility connections. It makes sure the building goes up in the right spot and can be properly hooked up to water, power, etc.
So each document has its own very specific job, from planning and budgeting through the actual build to making sure it fits on the land correctly.
Got it. Now, the notes also mentioned front elevation drawings. What are they showing us?
A front elevation drawing is basically what the building looks like if you were standing right out front looking straight at it.
Like a picture of the front.
Pretty much, yeah. It shows the vertical arrangement doors, windows, the roof line, the overall look of that face of the building. It helps everyone visualize the finished appearance from that specific angle.
So, the building's face. Now, when we look at these plans, we see all these dimensions written down. How do we actually figure out the real size of a room from those lines and numbers? We had examples for a bedroom and a living area.
Right. To translate plan dimensions into actual room size, you need to understand what the measurements cover. For, say, bedroom 1, you might see an overall length measurement on the plan.
But that often includes the thickness of the walls at each end. So to find the usable space inside the room, the space you can actually put furniture in, you have to subtract the thickness of those walls. Same for the width. Take the total width shown, subtract the walls defining that space, and you get the actual size of the room you'll live in.
Ah, okay. So the lines on the plan often measure maybe center to center or outside to outside of walls, and we need to account for the walls themselves to get the clear internal space.
Yeah.
Makes sense. And finally, this idea of drawing scale. Why is that so important, and how do architects decide which scale to use?
Drawing scale is absolutely fundamental because we're trying to represent something real, often something huge like a building, on a much smaller piece of paper.
Right.
The scale tells you the ratio between the size on the drawing and the real size. For instance, a common scale is 1.50L. That means 1 unit on the drawing, say, 1 millimeter represents 50 millimeters in the real world.
So everything's shrunk down by 50 times.
Exactly. Everything is shrunk proportionally. If you ignored the scale, well, you might order materials based on the drawing measurements, and they'd be ridiculously small.
Yeah, that wouldn't work. So how do you pick the right amount of shrinking, the right scale?
The main thing is making sure the whole building or the part you're drawing fits comfortably on the paper. But also, it needs to be large enough to show the necessary details clearly.
Balancing act.
Totally. In our example, a building about 10,700 millimeters by 6,100 millimeter needed to fit on paper maybe 260 by 196 millimeter.
Okay.
They figured if they used a 1.50 scale, dividing the real measurements by 50, the biggest dimension would become about 214 millimeters on paper, which fits nicely. The other dimension shrinks proportionally too, and also fits. You generally want the largest scale possible that still fits everything on the sheet without it being too cluttered, so you can read the details.
So it's about fitting the big picture while still seeing the important little things. Makes perfect sense.
Exactly right. Understanding the scale is key to correctly reading any technical drawing.
Well, this deep dive into the basics of architectural drawings has honestly taken away a lot of the mystery for me. It's pretty amazing how these, seemingly simple lines and symbols pack in so much information, and how crucial they are for turning designs into real buildings.
And it's worth remembering, I think, that even if you're not directly involved in building stuff, having a basic grasp of these fundamentals can really deepen your appreciation for the spaces we live and work in,
Yeah.
and the incredible amount of thought and precision that goes into making them.
Absolutely. So the next time you happen to see a set of plans, maybe for a home reno you're dreaming about, or just a new development going up nearby, take a second look. Think about those basic lines, those symbols we talked about, the dimensions, the scale. What new details can you maybe decipher now about the vision that's about to become reality? It really is like unlocking a kind of hidden language all around us.